Welcome back to the deep dive.
Great to be here.
So today we're pushing past, the hype cycle we've all been stuck in for the last couple of years.
It's been a while.
I mean, everyone listening has played with the chatbots, you've generated emails, you've maybe summarized a PDF or had it write a wedding toast.
Right.
That's the voice of AI. And it's impressive, sure, but it's really just text in, text out.
It's a conversation. But the source material we're looking at today asks, I think, a much more interesting question.
Oh.
What happens when the AI stops just talking about the world and starts actually acting in it?
Exactly. We're moving from the era of large language models, LLMs, to what the industry is calling ADKs, agent development kits. And honestly, the best analogy I found in the reading, this really made it click for me, is that if LLMs are the voice, ADKs are the hands and the brain.
That's the perfect metaphor for this.
Yeah.
It really is. Because right now, even the smartest LLM is basically a brain in a jar. It might be a genius, but it's locked in a server room. It's isolated.
Yeah.
It's reactive. It just sits there, waiting for a prompt.
It has no agency. It has no idea if the room you're sitting in is on fire.
None.
It doesn't know if a machine next to it is jamming. It has zero sensory input unless you physically type it in.
Precisely. And that's the problem the agent development kit solves. We're moving to the agent. An entity that isn't just a text generator. It's something that can sense, think, and then act.
On its own.
On its own. To solve a problem without waiting for a human to hit enter.
So our mission for this deep dive is to get from conversation to collaboration. And we're not just going to talk theory.
I'm glad to hear that.
No, the sources give us a really solid blueprint. So we're going to mentally build a smart office agent from scratch. We'll look at the hardware, the Python logic, the safety protocols, the whole stack.
I love that approach. It's really the only way to get the difference between artificial intelligence as a buzzword and actual agent engineering.
Okay, let's start with the anatomy. We mentioned the brain in a jar. How is an agent fundamentally different from an LLM?
It all comes down to the operational loop. An LLM is linear. Input, process, output, done.
Stop.
An agent, built with an ADK, runs on a continuous loop. It's called sense, think, act.
Sense, think, act. Okay, let's break that down. It sounds simple, but the implications feel huge.
They are. First, sense. This is live data intake, not a static file. It's reading temperature, motion, light levels.
Vibration from a machine.
Or even an API feed from the stock market.
Yeah.
Anything. Then think. It reasons over that live data.
Mm-hmm.
It's looking for patterns, anomalies, or triggers based on the logic we give it.
And finally, act.
It executes a command.
And that act part is where the stakes just change completely. The source used a factory robot example that was just perfect for this.
Yeah, that was a good one. Think about a standard robotic arm on a conveyor belt. It's automation, but it's dumb automation.
That's a script.
It's a script. Move left, move right, repeat. If that conveyor jams or a motor overheats, the standard robot just keeps going.
And creates a total disaster.
A disaster.
Yeah.
Because it has no awareness. It's blind.
Right.
But now you swap that for an agent. It's reading vibration sensors on the belt. It senses the jam because the vibration frequency spikes. It thinks, okay, high vibration equals mechanical failure.
It acts.
It acts. It shuts down the line. It might trigger a cooling fan. It alerts maintenance.
And it did all of that before a human even knew there was a problem.
That is the key shift. It's not just a tool you use anymore. It's a partner that works alongside you.
Okay, I want to get into the weeds. Let's build one. So if you're listening, put on your hard hat. You are now the facility manager of a modern office.
I'm ready.
The mission is to build a smart office agent. Where do we actually start? Do we just start buying a bunch of sensors?
No. And that's where most people go wrong. You don't start with the code. With agent engineering, you have to start with the goal. Step one is defining the problem. If you don't give an agent a specific objective, you just get noise.
So for our office, let's say the goal is efficiency and comfort. We want to monitor temperature and lighting, optimize them for when people are actually in the rooms.
So you're not cooling empty spaces.
Exactly. And alert the team if a system fails.
That's a solid goal. Now we can move to step two. The inputs, this is the sense part of our loop. We need to give the agent its eyes and ears.
Okay, so the obvious ones are hardware sensors, thermostats, motion detectors in the ceiling, maybe light sensors by the windows.
All good. But the source material made a really good point that inputs aren't just physical hardware. This part kind of surprised me.
This is a critical insight. If you only look at what's in the room, you are missing half the picture.
Okay.
You need context. So you plug in software inputs, specifically external APIs.
Ah, like a weather API.
Exactly. If the agent knows it's 95 degrees outside, it understands why the cooling system is struggling, gets predictive power.
Right.
But even more important for an office is something like the Google Calendar API or the internal meeting schedule.
Oh, of course. Because a motion sensor is reactive. It tells you the room is empty now.
But the Calendar API tells you the room is booked for a huge board meeting in 10 minutes.
Precisely.
Yeah.
That is the difference between a reactive thermostat and a smart agent. A reactive system waits for people to walk in, realize it's boiling, and then complain.
The agent sees the calendar, thinks ahead, and pre-cools the room so it's perfect when they arrive. That's real situational awareness.
Okay, so we have senses, the hardware, and context to software. That brings us to step 3, the actions, the output.
And again, we have to unlearn our LLM habits. The output is not a paragraph of text explaining the temperature.
No, the output is a command payload.
You're talking about sending actual signals to the HVAC controller to drop the temperature.
Or to a smart switch to dim the lights.
Communication is still an action though, right?
It is, but it's often secondary. It might ping the facility team on Slack, I adjusted room B because humidity spiked. But the primary output is a physical change.
So we have the concept mapped out. Inputs, context, actions. Now we need to actually assemble the machine. Step 4, the architecture.
This is the brain and limbs part.
Okay.
The source breaks this down into 3 components: the logic engine, the nervous system, and the muscles.
Let's start with the logic engine, the brain. The source points to Python.
Yes, Python is pretty much the language of choice here. The libraries are just so extensive. This is where you write the rules.
And it's just simple logic statements, right?
At its core, yeah. If motion is 0 for 15 minutes and the calendar is empty, then turn off the lights. It's the think part of the loop.
But Python is just code on a server. It can't feel the room. That's where the IoT hub comes in.
Right, the Internet of Things hub. Think of this as the central nervous system. You've got hundreds of sensors, light, heat, motion, all just screaming data at once. Different protocols, different data rates. You can't just plug that chaos into your Python script.
So the hub is the translator.
It's the aggregator, and the normalizer takes all those thousands of data points, cleans them up, and feeds them to the brain as one structured stream.
I see. So without it, the brain is just overwhelmed.
Completely.
Okay, so the hub gathers the sensory data. Python decides what to do. How does it actually flip the switch? It doesn't have fingers.
It has REST APIs.
The limbs or the muscles.
Exactly. For anyone who isn't a developer, an API is just a standard way for 2 pieces of software to talk. The Python brain sends a little packet of data, usually some JSON, to the lighting system.
And it just says set brightness to 50%.
And the lighting system receives it, validates it, and makes the physical change.
So to recap the synthesis, the IoT hub feels the environment senses, Python processes the logic brain, and the APIs execute the command limbs.
You have just built a functioning body.
But we're not done. If we stopped here, we would probably get fired.
Probably.
Step 5 in the source is where the rubber meets the road. Testing. And they made a really good point. You don't test for when things go right, you test for when things go weird.
The edge cases. This is absolutely vital.
Yeah.
In a chat window, if an AI messes up, you get a weird sentence. In a smart office, if an agent messes up, you could freeze your employees or leave them in the dark.
The late-night worker scenario was the example. I think we've all been there.
Oh, yeah. You program the agent to shut everything down at 7 p.m. to save energy. Makes total sense on paper.
But what about the person finishing a deadline at 8?
Right. If your logic is too rigid, the agent just cuts the lights. The employee waves their arms, the lights come back on.
And then they turn off again 15 minutes later.
Because the night mode rule overrides it.
That is how you get employees smashing your expensive sensors with a broom handle.
Exactly. And that fails the mission. So you have to simulate that.
Yeah.
You refine the logic to say, if motion is detected after hours, extend the on duration. Or check the calendar for overtime blocks. You have to stress test the logic against human unpredictability.
Which leads right into step 6. The source calls this ethics and safety, but it feels more like reliability and control.
They're guardrails.
Yeah.
And the source highlights 3 technical requirements here that are basically non-negotiable.
The first one, manual overrides.
Always have a kill switch.
Yeah.
It's rule number 1. If the agent goes rogue, Maybe a sensor breaks and sends a value of -50 degrees, so the agent blasts the heat.
Until the boiler explodes.
A human needs to be able to walk over, hit a physical switch, and say, I have control. You never, ever build a system that can't be physically disconnected.
It's the break glass in case of emergency. The second requirement is logging. This gets at the black box problem.
Right. If the heat turns off at midnight, the facility manager has to be able to look at a log file.
And it needs to say what happened.
Action. Heat off. Timestamp. 12.00 a.m. reason. 0 occupancy detected. Because if you don't know why the agent acted, you can't debug it.
And if you can't debug it, you can't trust it.
Exactly. Transparency is a technical requirement, not just a moral one.
And the third requirement mentioned was user consent, which in an office really means visibility.
It means people need to know the system exists. If you have cameras and sensors watching your employees to optimize comfort, they need to be aware of the parameters. It's about setting expectations.
So the smart agent doesn't feel like a spy agent.
You got it.
Okay, that makes total sense. Now I want to zoom out a bit. We've been very focused on this office, but the sources make it clear this isn't just about making offices a little more comfortable.
Oh, the landscape is massive. We're moving from the smart office to the smart city.
Okay, give me the high-stakes version of that. What's an agent look like on a city scale?
Traffic flow is the immediate application. Right now, most traffic lights are just on timers. They're dumb loops. Imagine agents controlling the grid. They use cameras to sense traffic flow in real time. But here's the think part. They see an ambulance approaching 3 blocks away.
So they talk to each other.
Agent A tells Agent B, emergency vehicle incoming. And they act. They turn the lights green to clear a path before the ambulance even gets there.
Wow, that's actual coordination. That saves lives by shaving minutes off response times.
Literally. Or look at healthcare. This is one of the most promising areas for ADK tech.
We're not talking about robot surgeons, though.
Not yet.
Yeah.
We're talking about monitoring agents. Think about your wearable device. Right now, your watch tells you your heart rate. That's great. An agent analyzes that data 24/7. It's looking for trends, not just numbers. It can spot a subtle arrhythmia or a drift in your baseline metrics that a yearly checkup would absolutely miss.
And then it acts.
It alerts your doctor weeks before you might have a major cardiac event. It gives the medical team a continuous stream of analyzed context.
Not just a snapshot from when you're in the clinic.
Exactly. It's watching the whole movie, not just looking at a photo.
What about agriculture? The source mentioned precision farming.
This is huge for resource management. You put sensors in the soil. The agent monitors moisture and nutrients inch by inch.
So it only waters what's needed.
It automates irrigation, but it's surgical. It only waters the plants that are thirsty exactly when they need it. It saves water and boosts yield.
And finally, finance. I'm guessing this is already happening.
It is. Fraud detection is the classic sense, think, act loop. Sense the transaction stream. Think. Is this purchase pattern normal for this user?
Or is it weird they're buying electronics in London when they just bought coffee in New York an hour ago?
Exactly. And then act. Freeze the card instantly.
So the common thread here in all of these is that we're outsourcing vigilance. The agent is the one paying attention, so we don't have to watch a screen 24/7.
That's the key takeaway. The ecosystem is moving toward smarter, connected systems designed for autonomy. We're leaving the era of human uses computer.
And entering the era of computer works alongside human.
Right.
Okay, let's wrap this up. We started by asking if AI could do more than just write poetry. We found out that with ADKs, they can absolutely act. We walked through the build.
Hardware senses, Python brains, API limbs.
And we realized the code is kind of the easy part. The hard part, the real engineering challenge, is building the guardrails.
The testing, the overrides, the logging. That's what separates a cool prototype from a system you can actually deploy.
So for the technical listeners out there, and I know we have a lot of developers, the call to action from the source is clear. Don't just get good at prompting ChatGPT.
No.
Look into the open source ADK libraries, buy a Raspberry Pi, get some sensors, build something that actually does something.
The tools are all there. The barrier to entry has never been lower. You could build a basic agent in a weekend.
And I want to leave you with a thought that kept nagging me while we were discussing this partner aspect.
What's that?
If we're building agents that have autonomy, that make decisions, that optimize our environment and watch our backs, at what point does our role fundamentally change? At what point do we stop being operators of technology and start becoming managers of relationships?
That is the shift. You aren't debugging code anymore. You're managing a workforce.
It just happens to be a digital one.
Yeah.
Something to chew on next time your smart home decides you need a little more light. Thanks for listening to The Deep Dive.
See you next time.